pickaxe or whatever.
Marquee tab.
But there's a game prototype on there called Raspberry. It only runs on Windows, sorry. And so the idea behind this was a little bit different, but it was about combining game mechanics. And I didn't think about it this way. But it was like, okay, what if you made a game where you tried to use game mechanics like music, where you'll have one interaction that's like you're trying to click on things or something, right? And you have another interaction that's like you're trying to dodge things. And what you could imagine some number of very simple things like that. And then like in a song, you might have like drums come up really loud for a little bit and do stuff. And then you'll have, guitar come in or whatever. And sometimes you have everything and sometimes you have one thing. It was about just composing these gameplay interactions in that way over time. And it was a good experiment. What the conclusion that I came to was you can't exactly do that in the same way that music works, because game design is like fundamentally a little bit lower frequency in the sense that the rate at which your brain can track the changes in what you need to do has some maximum rate before it just is not that fun. But it did work in the sense that like, oh, this is kind of cool and interesting. And maybe I should ship, I would have to dig it out of source control and compile it again, which, oh my God, compiling a C++ program from 15 years ago is difficult. But, yeah, that was related. So I think it goes to show that I've been thinking about this kind of thing generally for a long time. Yeah.
Would compiling a Jai program or a J program or the language program in 15 years, will that be a challenge or will that?
Well, it depends. So part of the reason we're keeping it in closed beta right now is to give ourselves the permission to change things in a somewhat incompatible way. But because there are like 1,000 people in the beta now, we still try to smooth it out. So like what I'll do is I'll say, okay, this feature's going to get deprecated and replaced by this other feature. So first we implement them both alongside each other, right? Then a month later, this one gives you a warning when you use it, right? And then a month later, it gets deleted. But if you take a year off and come back, you might have missed that, and now your program just doesn't compile, right? And there's information in the changelog about why, and sometimes we can even leave error messages that say, oh, this isn't how it works anymore. But yeah, so now there's different levels of changes that are different levels of severity and stuff, right? But what I would say is, okay, so the reason we're doing that is because of my experience with languages like C++, where they had a lot of ideas early on about like what would be really cool ideas and make programming better. And a lot of those ideas are very inaccurate. There were other things that they really should have done early on, like that C didn't really do. And not to blame C, but like in the days of C, it didn't make sense to think in a very clear way about integer types, let's say, because there were just all sorts of computers with all sorts of different word sizes. You didn't know what was going on and like all these things. But like now it's like, it's pretty obvious that like if you have an unsigned 8-bit number, that'll fit into a signed 16-bit number, right? If you just, and that should implicitly cast, but if you have an unsigned 16-bit number and you put it into a signed 16-bit number, you maybe should say that that's what you meant to do. Right. And it eliminates, and like they weren't thinking about that kind of, I'm not even saying that that's exactly the right decision that you should make, but it's like a clear idea that should have come up. Right. And they just weren't thinking about that stuff. And they had all these other things that they added to the language. And the problem with C++ now, or one of the many problems with C++, I would say there are two core ones that drove me to make a new programming language. One is that C++ is completely saddled with almost all of the baggage of almost every idea that was ever introduced, and there's no way to deprecate things, right? So that's a problem, and so that makes the new features worse. So if you actually have a better feature that actually will help people, it actually doesn't work as well as it should, and it's harder to implement and slower because it has to interoperate with like all this cruft that's like built up over time, right? And so there's a lot of things they just can't really do. Like I haven't tried to use the modules feature. I sort of froze my C++ usage at C++11 and even only some of C++11. Like I do, probably less severe than, like Casey, you actually use C++. You just don't use most of the features, right? But you use the compiler.
I kind of gave up on C++ features a while back.
Yeah. But like Sean Barrett didn't even use the C++ compiler forever, right? Like he was using the C compiler, which was not maintained anymore. But he was like so much faster than the C++ compiler.
Same with Jeff Roberts. Still I believe to this day, when he has his own stuff, if he doesn't have to interoperate, it's the C compiler only.
And like you can't, so in that dialect of C, the last one that Microsoft made this compiler for, you can't even like declare a variable in the middle of a block, right? Like
What?
Only at the top.
it's bad. Like original C was really different from modern C.
Yeah.
Yeah,
actually.
modern C has like added a bunch of those conveniences in now, so it doesn't feel that clunky. You can program in straight
modern C. Are we talking like 89? Are we talking 99?
Well, I haven't followed anything since ANSI C, right? I know there's like C99 and stuff. I don't know what those features are. I don't care.
Really, we just mean if you go download a C compiler today, whether it's Microsoft's or Clang or GNU C, they now all have things that you would have been very happy to have way back when, like including like how like a for loop might get scoped for variable declaration.
Oh, yeah.
Or how you would whether you could use declare anywhere, those sorts of things. They didn't have any of that, right? You had to put all of your variables at the very top of the function and all that sort of thing, right? That was still the norm in like the year 2000.
So K and R C, when I was in college, I was learning C, and there was this shiny new book that said ANSI C with a big stamp on the front. But in the used bookstore, they had a book that looked almost the same. It was the same like C programming language book without the ANSI C stamp. And I was like, that's pretty cheap. I'll learn from that book. And that was the K and R version of C. And so I was using compilers at school that could do the newer C stuff, but I didn't know that. And so in K and R C, for example, if you're going to call a function that's in another file because you're organizing your program, you don't declare the arguments of the function. Just whatever you pass to that function, the compiler says, sure, that seems fine, right? And so then you spend all this time debugging because like you passed a double instead of a float, or you forgot an argument or whatever, and you just crashed at runtime, right? There was no static type checking on external functions. So that was
feels like my experience with Elixir. I did this very regularly, tried to pass things in and getting the wrong types constantly.
Yeah, it's exactly what you need when you're just trying to learn, It's
Well, I mean, we say this, but like, welcome to JavaScript, right? Like fast forward to today, and like a very standard programming language is still in the state where it's like, yeah, I don't know, you just pass something, and
Whatever you want, man.
Whatever you pass is what gets passed, and good luck.
Yeah.
yeah.
I mean,
Right?
to be fair, most modern JavaScript, they use, TypeScript, which alleviates a good portion of those problems. There's still the problem of outside objects coming in. You have to literally hand validate them with some sort of runtime checking to
You
prove
say
that
most.
they are what they are.
Are you sure most is true here, though?
It's like all like 75% of new projects. Or it's like some
Okay.
decently good number these days. But
well,
nonetheless,
that's
it's still,
nice. That's nice for the youth of today.
That's nice that the web finally figured out about
Yeah.
types.
My favorite part still is that we take a language that cannot be interpreted and turn it into a language that can be interpreted, and we call it compiling. It is like we're in a very weird world in that side of the universe, but it's very fun. All right, so I want to actually steer away from I love the C++s and. Well, actually, I don't. I actually genuinely hate it. But
Yeah.
this is great discussion, all. But I actually want to focus on kind of a question with Jai.
Sure.
Or Jay. By the way, do you call it the language, Jay or Jai?
Yeah, I
Or
don't pronounce it.
Or
So-
John's artificial intelligence.
So I have an allergic reaction to one of the so I'm very frustrated with the quality of software, broadly speaking, right? And part of that is the culture of what are people thinking when they sit down and make software, right? And there's a pattern that I notice that bothers me that doesn't seem to bother a lot of other people, but both in academia and industry. If you read an academic paper that's about somebody's algorithm, right? There's a very classic form, which is they put the cool name of the algorithm that they made up, like the marketing name, colon, and then they tell you what it means. And Hacker News posts are the same, like Django poop, colon, a thing that converts all your comments in JavaScript to uppercase, right? and like they come up with like the seemingly, this is my cool project name for like something totally stupid. And it's like all the effort goes into thinking about the name, or like thinking that if you make a really neat name, then you've passed some hurdle of being a contributor or whatever. And Meanwhile, I'm trying to implement this algorithm from a paper, for example, in a video game, and like realizing that it doesn't actually work. And then sometimes under very strict deadlines where I suffer greatly due to this, and just, it really frustrated me. So this was just like a code name that I made for this language. I don't ever use it. We don't market the language. I don't have a logo for it, which is another thing that people make like first before, and even when it comes to language syntax, like if you start talking about what languages should a feature have, people will talk about the syntax because it is the most concrete and easy to observe thing, but it also kind of doesn't matter that much. I mean, it does matter at some point, like in the end, once you finally have a tool that you're like, this is the thing I'm going to use day to day for years, then small amounts of friction do add up and they really matter, right? But the problem is that if those are the main things you're concerned about when you're designing a new language, those are relatively shallow problems that you're preoccupying yourself with. And what I found, okay, so let me get back to this other thing that you sort of asked at the beginning, which was like, why did I make the language? Part of it was I was sitting there using C++ every day. So Casey visited in these days and worked on The Witness. And we had both an annoying like asset processing pipeline for the game, which I won't explain that right now, but it's like, crunching the data that's going to go in the game sometimes would take too long. And that slows down your work process. But also just compiling the game was really annoying. It would take like a couple minutes, which doesn't sound that long, but it like really breaks your flow when you're trying to think about stuff. And it was only a couple minutes because we spent a lot of effort trying to minimize the C++ suffering about how long things take. And so I was like, I have all these problems. Like I was kind of sad and depressed working on this game, even though it was the best thing I had ever made. And it was clear that it was going to succeed at some level. I mean, who knows about commercially, but like artistically, we had at that point succeeded in making a good game. We just had to finish it, right? And I was still bummed out going into the office every day, just working on this thing. And I was like, okay, part of this is the programming language and part of it is the asset stuff. And the asset stuff we can look at next time we make an engine. The processing, the programming language, though, I would go online and look at what are the conversations people are having, because like there's a C++ committee, right? And then there's other people making other languages, and like why? What are they saying is their motivation? And I would look at the problems that they say that they are solving, and they had very little to do with the problems that I had from day to day that was making it hard, right? And the thing is, like when you're working on a smaller program, or you're working on or you're a new programmer, right? You feel like there's certain things that are serious problems, but actually when you get more experience, you're like, yeah. Like you don't really make that many syntax errors when you type later. But if you're a new programmer, you're like, syntax errors are really, I'm drowning in syntax errors.
Like
this is obviously a
you
big
have no
problem.
idea. You're like, what? Why? What? Yeah.
Yeah, now it is true that better syntax error messages can help people learn really fast, but that's not like a deep. So what I found was that once, and I think this is obvious once you say it, but like once programs get past a certain size of code and or, because it's like some kind of product function, and or a certain complexity of like the internal data and how it has to be arranged and like, what the structures look like and what the constraints are. Once it gets past a certain point in complexity, it's just hard to work on the code because it's hard to understand everything and see everything and just know what's going on. And that's kind of the bottleneck, is that it just gets complicated. And so that's what I wanted help with, was like code that just gets really complicated. And I was looking at what people were talking about, and they just didn't have any of that as a concern. And then the other thing, it was compile times, because
Can I inject one thing there too?
Yeah.
Like when you look at like the biggest thing that frustrates me when I've looked at things like C++ committee discussions, or how they go about like deciding what and how to put in the language, is the mindset, in my opinion, when you're designing a language, has to be that we are trying to make the best possible system for the working programmer. Like the person who's going to sit down and is trying to get their job done that day. That is what you need to, unless you are making, like if you're making some abstract, like, like ML or something like this, or Lisp, and you're intentionally going down that road to make a theoretical language, then that you do whatever you're trying to explore. That's your thing, and that's fine. But if you're like the C++ committee, your job should be to focus on what is going to allow the working programmer to have the tools they need to succeed every day, right? But if you actually look at the way that they make decisions, it's almost all about weird, esoteric, theoretical things. Like, they will never go like, okay, well, we have to make this thing work because this is what would actually be effective in day-to-day work. So we'll go and we'll deal with ugliness in the theoretical realm or something as a result. They will never make those decisions. And it always ends up feeling a lot like, you know, you're in some like rundown, like dilapidated shack, and someone is like, okay, we've got this beautiful mansion that we're gonna move to, and they're like, whoa, we can't move to that mansion. I planted this tulip bulb back at the shack, and I don't know how we're gonna move that, right? And like literally, like you're reading, like, well, I'm like, what? Like you guys decided you can't do any of these things in the good way that you would have done them because of this one little thing. And no, this is why the language keeps getting worse. And so I do think like there's in some languages, they've calcified this very academic process for like moving the language forward. And it always results in substandard features over and over and over again. So anyway,
and can I also say it does feel a little bit different too if it felt like, I mean, we already made the joke about it being impossible to build an old C++ project. It'd be one thing if I could pull any C++ project out from any time and they're like, you have a random one from 1997, you can compile.
Yeah,
But
no, you
I
can't.
feel like I never, so it's not even like you're getting this feeling of like, oh, I have this rock solid thing I can always build. It's like, we're going to keep all the features around, but you still can't build it? Like, what is that?
you get nothing from it, yeah. So
Yeah,
anyway,
that's like the history of all of computers, really, is like there's these stated reasons why things are the way they are. We need to do it this way to get this benefit, and then you actually
Yeah.
ask if you get the benefit, and it's like, well, we get 5% of the benefit.
yeah, they're like, no, not really. Yeah. Yeah.
So question would be, is that a design by committee problem? Because John, you're effectively the decider of the language. You're the benevolent dictator of it.
Yeah.
And so do you avoid a lot of those problems because you look at the tulip and go, I'll just plant a new one. Like, you can just make that decision. You don't have 5 people of the 10 being like, that tulip is life. I cannot let go of the tulip. Like, you don't have to make those fights. You can just say, no, this is the way. It's the best way.
Yeah, what I would say that the problem still occurs even if you have a benevolent dictator, because you do want to listen to your audience a little bit, at least, as part of a grounding. Like, so even if you think you have the best ideas and nobody else can have better ideas, which is not usually exactly true, you still need to listen to people to know, like, okay, I have an idea that doing this feature this way will help a certain class of program. There's people out there writing that class of program. They can tell you if that feature actually did what you meant it to do or not. You can't quite do all of those yourself because you're, like I said, the real problems happen when you're like deep in a very complex program, and you can write like little demo programs to test your features out and stuff, but you just don't have enough human life years to like write all these super deep programs. So you need to talk to the people who are using your thing, and they're going to have all different opinions about what you should do, and you need to just like not listen to some of them. Like that's simply how it is, because if you listen to everybody with an equal weighting, it is equivalent to design by committee. And so you just have to say, I'm sorry, it's, you know, for some people, it's not that you necessarily have a worse idea or anything like that, but this language has to pick a direction to go, and it's just not that direction, and maybe a different language could go that direction, right? And maybe that's better. Like, we're just, you know, you're doing some hill climbing process, right? Where hill climbing is this thing in computer science where you start out on some landscape and you only can look nearby probably, and you just go the way that seems the best, but you don't exactly know. And this is an entire class of algorithm in computers, right? And so you're kind of doing that. But you have to, if you listen to everybody, you'll add up all these vectors that point in all these different directions, and they will sum to 0, and you will not go anywhere, right? And so so you just need to be willing to be a little bit, like, not even exactly disagreeable, because you don't have to argue with people or anything, but it's just like, look, that's just, I appreciate that you want this thing. It's just not what we're doing here.
You have to have conviction.
Yeah, something like
Doesn't
that.
have to. Yeah, yeah. Mhm.
You have to not
and
be
an
a super
ideology,
people
right? Like,
pleaser.
here is what we're trying to accomplish that
Right.
includes some things that you will take seriously and some things that you will just decide we're not going to do. Like, right? If you tried to do, I mean, C++ also has a little bit of that problem where they don't have a strong idea of exactly what we are trying to accomplish at the end of the day.
Everything.
So, right?
All-
Everything
all
and
the-
nothing,
accomplishing all the things.
sort right? Like they all, it's everything and nothing somehow, right?
Yeah.
And so it also pays to have, separate from design by committee or not. If you're going to have a committee design things, it helps to have an overriding idea of like, we are trying to get the language to this place and accomplish this thing, so that we have like a guiding principle. Like I said, like make the working programmer's life easier every day or something. Like there's something like that you could point to, so that somebody on the committee can argue, look, we're just going to have to trash the tulip because we really need, like, this mansion is going to be so much more helpful for everybody, and we need it to be good or whatever. But anyway, I interrupted John when he was about to talk about compile time, so maybe we can jump
Oh yeah,
back.
well so
That's number
there
two, you
are
said.
there are friction things, and so when people talk about like, oh, the syntax needs to be good or whatever, they're talking about the minute-to-minute pleasure of using a language, and for some reason people focus on that, and then it takes 2 minutes to compile "Hello World" now, and it's like, what happened? How am I supposed to have a thought process? How am I supposed to develop when it's like so painful that I just sit there and wait to see what happens? And so that was an emphasis from the beginning. Also, because I come from the world of video games, like even a video game 10 years ago did an insane amount of computation in one frame, especially on the GPU, which is a highly specialized, very parallel thing. But even if you factor that out, the amount of stuff that a video game does just to figure out what to put on a screen is very high, at a very high rate. And it's because that was just like the fitness function under which the industry evolved. People wanted games that rendered smoothly and looked good, right? And like for some reason, no such fitness function exists in programming languages. There is one, but it's like, it's something about how cool of an anecdote can you post on Hacker News or something, right? It's like it's not really to do with usability. I mean, at some level there is, I don't know, it's complicated, but so looking at these compilers, I was just like, look, I've written compilers before, never as serious as this one, but like in college, I wrote like 12, instead of doing my homework and doing classwork, I wrote like 12 compilers for different languages. And so I knew how it worked and I knew what they were doing under the hood. And I was like, it's way less computation than a game does actually. And so it should be really fast. And so, part of the goal was to just try and fix that. And because, we've done a pretty good job at that. So our 300,000 line game does a full build. We don't have incremental builds because that's, in my experience, another source of bugs and confusion. Like, even the more you have to think from minute to minute about what are all the different ways that a thing might be building and which one is selected, right? It's just another roadblock. And so it's just like, look, it's a full build all the time. Right now, that takes about 2 seconds for a debug build, which is longer than I wish it was. I wish, I feel like it should be like a quarter of a second. But, we've reached the point where with the team size that we have, it's hard to push that number down without concerted effort, and we're still trying to ship the game and all that, right? But that's still, a lot of these other languages that have been made in the past 10 years, how long does it take them to compile a 300,000 line program? Like way, way, way longer. And it's just due to like decisions that are made about how the language works.
Yeah, 2 seconds is a lot less of a temptation to pull out my phone and forget everything that I was doing than 2 minutes or 20 minutes.
Yeah,
right?
it's like just short enough because if you turn around to do anything, the prompt will come back up, right?
Yep.
Yeah.
Dang,
It's actually like 1.7.
Personally, I think it's really impressive. 300,000 lines for 2 seconds. In modern development, that is genuinely unheard of. Because, even in my personal, interpreted languages, as of recent, it often takes more than 2 seconds for significantly less lines. So this, that is actually, in modern sense, a very impressive feat.
Yeah, so that's something that our beta users enjoy, significantly, is that sped up iteration.
I know we've got a hard stop. I got a few last quick questions for you, if that's all right. So
Sure.
They might not be quick, so then you don't have to answer them too. So we'll just
one word answers.
All right, okay.
Good, because I got some too.
All right, here you go. Do you think that AI is going to save the games industry by forcing RAM and GPU prices up so high that people actually have to care about performance?
Interesting take, Teach.
I'm not sure. Okay, we'll not try to one word answer that. Here's the thing.
You can also include web development as well.
Yeah.
Well, yeah, I don't do web development much ever.
Yeah.
But like, so this is a problem. Like, games for a while was known as the place where there were still a lot of really good programmers because we were like forged in this fire of really difficult stuff, and that's become increasingly untrue. I think game programmers are like reverting to the mean, and so it wouldn't be too bad. I don't think that, like, I think things are going to adjust and RAM prices are going to come back down pretty soon. This is just a short frequency trend, like all of these.
Yeah.
But yeah.
Prime, you want to ask one? We can alternate.
Yeah. Common wisdom says, or at least common wisdom on Twitter, so it may not be actually wisdom or common. It suggests that you should be making a game and getting it out fairly fast and making sure your concepts are good and getting it in front of people and all this kind of stuff. You shouldn't go and hide yourself away for many years to build one game. You obviously having the time to build a language, build an engine, then build a game, 10 years total. When do you make that decision to say, no, actually, taking your time, taking the 10 years, taking the 5 years, this is actually the more superior choice? Like, when do you know to make that decision?
For me, it usually happens gradually. So all of these projects I would have envisioned being shorter. Like, this game was supposed to be the proof of concept game with like a simple engine just to prove out the programming language. And it turned it, I just always want to do a good version of everything. And then, I don't know, there was like a lot of weird stuff that happened over development that I won't go into about like what different people on the team want and things. And so we ended up making an engine that's actually more sophisticated than the one for the last game when I was hoping for simple. But it means the game looks really beautiful. And but here's the thing. So I think that advice that you said is the right advice for someone new to games or just projects generally. Like, if you have never shipped anything before, you should not spend 5 years in a back room doing something, because you're going to be miscalibrated. You're going to be slow at what you're doing. You're not going to have the right amount of experience. And so being quick early is a good way to just iterate and learn, right? However, somebody's got to be working on really whatever you want to call it, like moving things forward and not just trying to release something and make some money. Like there have to be adults in the room somewhere who are worried about actually improving life in some way. And sometimes that's just really hard. If you could find a way to do that, in fact, there almost always is a way to do that that's actually small and incremental. It's just, that's not the way that I think, apparently. But for me, it's a lot more about motivation. Like, if you can, however long it takes to do something that's genuinely meaningful is how long you should take, if that's your lot in life. And that's different from the guy who's like, I'm supporting my family by having a job. That's cool too. That's totally fine. But we need some percentage of people who actually are trying to like lift up the quality of things. Otherwise, it'll just be an eternal slide into a pit that we never get out of.
Recently, also, oddly enough, there's been some examples of these kind of long gestating games that I think might have also been first times. Like, I want to say both
Blueprints was like 7 years or
Blueprints and
something.
Animal Well. I don't know if Animal Well was his first, though. We're both very long gestating, single person or close to it games.
Yeah, and so if you think
And
you
they took
can
a long
hit the
time,
target,
you know?
yeah,
And they sold fantastic. They were very, very popular, right? So it's kind of hard to guess what's going to happen. I think it's nasty.
Yeah.
It's
I mean, the
nasty.
thing that we don't see is how many of those did the same strategy, and they just didn't have the best idea or whatever. I don't know.
Yeah. Any advice for people balancing CEO of game studio and someone who wants to be programmer/designer?
So the way that I do that is by not CEOing very much. Because as you know, programming takes a lot of time, and game design also takes a lot of time. So one thing that I'm doing this time that helps somewhat is I did sign this game with a publisher. This is the first time that we ever did that. Part of that was to get additional funding to help finish the game, but part of it was just like they have a whole infrastructure for like doing stuff that left to my own devices I would do, but not as well. So like marketing the game, like they're running ads for the game right now. I wouldn't be running ads for the game right now. And like all these things, just like, so we're kind of delegating some of that to this other company who now also has a financial interest in the game succeeding and all that. And so I think that's good. I don't like want to run a business. That's never been my motivation, but I have to in order to be able to do what I want to do, because like nobody's going to pay you to do some weird thing that they don't understand. Now, in the earlier days, the game business was easier, and so I could kind of be a little bit more just lackadaisical, especially like when there was no teams. It's just me working on Braid and like with occasional contractors. It's a lot cheaper, and it's like you can just make whatever decision you want, and it doesn't matter that much. Now there's like a pretty serious burn rate, and there's people, and like. So I have to balance this. Like we have to stay in business and not be like constantly losing money year after year. But at the same time, if you turn into generic business making generic product, that's also bad because it's not what I signed up to do. And people are not motivated by that because there's just a bunch of the same slop out there, right? And so it's actually kind of hard. And the past couple of years, we have survived the massive slaughter of 2023 to 2024 that afflicted a great amount of game industry. So we'll see.
Cool. All right. So I don't know if you've answered this one anywhere. I could not find it. You don't have to give us an answer if it's still if it's a secret, but why did you call it Braid?
Some of these things are just creative decisions that happen at a relatively deep level that I don't like to explain them.
That's fine.
Because sometimes the magic is in the non-explained things. And so I'll just say there's some kind of, the idea for the game involves like a mood and a feeling and like a texture. And that was just part of it. And that's all.
Cool. That's fine.
All right, I got one that I feel like is really good for Twitter.
Okay.
If you could give a 2-minute, 1-minute piece of advice to all people coming into modern web dev.
I don't know
Because
anything
that's where a
about
lot of-
modern web dev. What? Don't do it. What do you mean?
Well, because that's where a lot of people enter into, right? Like that's
Sure.
that will always be the entrance, and because it's just the easiest to get something on the screen and theoretically make $1 million by making another chat wrapper. So,
Yeah.
so if you were to give somebody an advice other than don't do it, what would you say to them that could potentially put them on the right track? So in 10 years they look back and say that guy was right.
I'm gonna say what I think the right answer is, and
Okay.
this
You
may
can't say
not.
don't do it. You can say whatever you'd like. But
Yeah, still don't do it. But here's the thing. Okay, the web started. I saw the very, very beginnings of the web and chose not to participate. So just to spend like 30 seconds giving a little background, I was at UC Berkeley. I was in this place called the Experimental Computing Facility, which is just like students enthusiastic about programming. The GIMP guys were there a couple years after me. That's why the file extension for GIMP is .xcf, because they came out of like the same computing lab. A little bit of trivia for you.
I did not know that.
Yes.
I've always
That's
wondered
good.
about that.
So the X in XCF stands for experimental.
Yes. So this was like when, if you had a computer at home, it was like a Commodore 64 or like a not that good of a PC. You didn't have an equivalent of a Unix operating system at home. That was not a thing. And so if you wanted to program real programs on real computers, there were these workstation class computers that were in relatively short supply. There was a whole controversy that like the XCF snagged allocations from the university that were meant for another group called the Open Computing Facility. And there was like a war between the students about this. All that happened a little bit before I showed up. Okay. So there was a guy next to me named Pei Wei who wrote one of the first web browsers before I even knew what that was. It was called the Viola browser. It doesn't exist anymore, but you could look it up. And I was at an early conference and Mark Andreessen was there and everybody was angry at Mark Andreessen.
Some things never change.
Yes. He was making the Mosaic browser at University of Illinois Urbana-Champaign, and web browsers didn't have images at that time. They just couldn't display bitmaps on the screen. And there was a discussion underway that was one of these laborious committee discussions that Casey's talking about, because it was like, we're the web community. We want to make sure we think about these and do everything. And he was like, angle bracket img angle bracket file name or whatever, URL, boom, it puts it on the screen. And they were all mad at him for implementing that and having images in his browser before everybody else. So that was my experience of the web. And like, I didn't really love it. I didn't stay in web from that time. But it was so even Viola, right, was very visionary in the following way. It was not just a web browser that put the text on the screen, but it had an embedded programming language that was interpreted. It was a lot like JavaScript, but it was a different language. So it was not really semantically equivalent. And then JavaScript came again, a couple years later or whatever, 96 or whatever year it was, 95.
Yep,
When Brendan
4th,
Eich famously did it in
Java.
10 days, right?
Yeah.
The reason it made sense to do something like this in 10 days was that, like, look, it's just to change a couple state variables in the browser about whether they push the button or it's not for real programs. So it doesn't need to be very serious. And so we don't need to use all this. And we want it to be cross-platform. So it's just going to be a very lightweight language, right? Okay. Fast forward. And now it's like the language that most software is written in, right?
Yes.
Nobody
What
thought
can
that
be
was
written in JavaScript will be written in JavaScript is the considered truth of JavaScript.
And so the problem with all that is that somehow we forgot all this thing that we knew about programming. Like it doesn't matter what programming language you use because the computer knows how to run some back-end representation, which in the old days was machine language, right? So then you move to the browser, you're like, we want it to be portable, so it can't be machine language, right? But like, it wouldn't have even taken that long. If I had a time machine, it's like, do you try to find baby Hitler and re-educate him to be a kind and loving young boy? Or do you try to find Brendan Eich and say, look, spend 2 more days to make a little bytecode engine so that you're language agnostic on the front end, right?
Really big decisions there at the time.
One of software's biggest questions.
Yeah. So I don't know that. I'm not serious.
amazing.
Obviously, the answer is baby Hitler. I'm not. That's not really a joke. But because baby Hitler was so much earlier in time that maybe everything would have gone better after that. And yeah. So, but the point being, like it used to be before the web that like if you wanted a language with strong type checking, you had your pick of a whole bunch and they all worked the same and they all targeted the same backend at the same level of quality. So it's not like you were using some janky transpiler to like build some massive 10x too large amount of bloat code that you can't debug or anything. It's just like they would target. I mean, those things did exist too, but you didn't have to use them because you had choices, right? And like we threw all that away and we made this thing where like now there's an interpreter engine and it just runs this one thing and then you can have wrappers around that one thing, right? Okay, so now we also ostensibly have WebAssembly, but it just, because it came in later and people are not, like all these companies also benefit from the fact that they're the only few people who can make browsers, right, as well, that there's no competition there. And so like Google loves that, dude. That's why they put so many resources into the browser. And so they're disincentivized from making it easy to retarget, like to control your own computing environment, let's say, right? Because if there's a very simple substrate and you don't need Google's permission to have new features or whatever, they can't leverage that against you in the future as part of their more, like it would enable incumbent browsers to come in and displace their market share and all that, right? Okay.
It's actually worse than that because also you have companies like Apple who are actively invested in not having the web be very good because if it was, then you don't have to use the App Store.
Yes. Yo, there's like every...
And that's not hypothetical. They literally,
Yeah.
like you can literally go watch them do that in the minutes of W3C meetings, which I have done, and it's frankly pretty disgusting.
Yeah, so every big company has a different angle on this, but they're all kind of in common. Every angle is about kind of capturing more market share and preventing their current market share from being eroded in the future by competition, right? So that's... This is all a long-winded way of saying, okay, there's good things about a browser. You can just open a web page and there's a program running. And that's something that we didn't used to have. It didn't used to be that easy. But like we didn't have to throw away all the good things about system software to get that. And there's this fundamental confusion about this. Like, if you just targeted an equivalent to a machine language, but that's cross-platform, well-defined, it has some instruction set, and then the browser was interpreting that, which is, again, ostensibly what WebAssembly is, but it like doesn't quite get there for, I don't know, various reasons. And it's certainly not the default, right? But if we had that, you could run real debuggers on your web program, right? You could do all these things. And so getting that back, like, those tools are actually incredibly valuable if you want your software to be high quality, because they bring in a level of analyzability and understandability that we just didn't have once we made the jump to interpreted languages by default. So getting back there would be great. And so this has been a 28-minute long answer, by which I'm saying you could like work on